All right, your second to last topic of the year is on statistical models, just call it statistics. You have one test, which is going to be your mid-year exam, which is in week 5. What does that mean? I didn't get to decide that time. I was told that by senior leaders. So what does that mean? It actually fits perfectly into our timeline. But if we go too slow, then you're not going to get an in-class practice test that I'll mark. What it'll be is I'll finish the content, then you get the practice test to study going into the exam. You won't get that formal, I mark your practice test and go, oh, you need to focus on questions, etc. So basically, it would just go back to what you normally get, okay? In the first half of this topic, we're concerned with numerical variables, basically numbers. This is important because when we're talking about numbers, do you get a choice about the order of numbers? No, 1 is smaller than 2. 2 is smaller than 3. So as soon as we're talking about numbers, the graph, the shape of the graph is important. That's compared to categorical variables like hair color, where the order isn't important. I could draw a graph that had hair color black, blonde. There's no order to black, blonde. I could make the graph shaped however I want. If I had 5 people with blonde hair and 2 people with black hair, I could make it look like, the graph could look like this. Right? The 5 people there, 2 people there. But is there an order to hair color? No. So it could just as well be 2, 3, 4, 5, and then 2 on the other side. But if we're talking numbers, like numbers of pets, you don't get a choice. It has to be in order. So let's revise some terms that are going to be important. If you're doing science, these might be familiar to you. In relationships between 2 variables, there are the independent variable. Does anyone know what the other term for the independent variable is? It starts with an E. No? Explanatory variable. Which now that you know the name of it, kind of makes sense. The explanatory variable explains why the other variable changes. If I'm putting a higher horsepower engine in my car, what's going to happen to the speed of it? It's going to go up. The explanatory variable is the horsepower. Right? It is the variable that causes or explains the changes in the other variable that you're looking at. You must always draw this on the x-axis of a scatter plot. You don't get a choice about that either. The dependent variable, also known as, it starts with an R. Any takers? Anyone know what? Yes? Responding. Response variable. But responding is fair enough. Response variable. Why is it called that? It's the variable that changes because of changes in the independent variable. You could argue that that's why it's called a response variable, because it responds to the independent variable. This is always drawn on the y-axis of a scatter plot. Can you add those words to that, please, to save on writing all of that? Explanatory variable, response variable. The relationship between 2 numerical variables is known as their correlation. The correlation between 2 numerical variables is described with 5 characteristics. All right, let's look at direction, please. Can you scroll down to these graphs here? How the dependent variable acts while the independent variable increases determines the direction of the correlation. This also happens to be the general direction the points form on a scatter plot. If I'm looking at this left one here, girls, can you leave until after? As I go to the right on the x-axis, what's happening to the dots going on the y-axis? Are they going up or are they going down? Up. So in a positive direction for the correlation means as x increases, y also increases. What about for the negative direction? As x increases, what's y doing in the negative direction? Yeah, decreasing. And if there is no correlation, the points are scattered randomly. See how we've got no numbers yet? There is no maths in this part, but there is a lot of notes. That's why, hopefully you can see why I did the printing. So that's the first. There's 5 characteristics. We've talked about direction now. What's the second characteristic? Linearity. If a correlation exists between 2 variables, the point's closeness to forming a straight line is called its linearity. So if I look here, this is what a linear correlation looks like. Are all those dots perfectly on the line? They're kind of spread out. But if I look at the shape of what those dots form, does it look like a straight line? So that's a linear correlation. Points form a straight line. A nonlinear correlation, as soon as you don't see a straight line, points do not form a straight line, it's nonlinear. That's the second characteristic. So what have we done? Direction, linearity. The next is strength. If the data does form a trend, so it's not just randomly all over the place, if it's making a shape, the closeness of those dots to that shape is the strength of it. So how would you describe, are those dots really close to that straight line shape? So we would say that's strong. I know you're in 2025 and you describe middle things as mid, but we're not going to say that the exam. So what's a more professional way of saying something's in the middle? Starts with an M, but you wouldn't say medium correlation. Moderate, have you heard that word before? If you want to say that the word moderate correlation, yeah, the dots are forming a line, but they're not super close to it. And then weak correlation for when the dots are, yeah, they're forming a shape, but they're not real close. They're just hanging around. They're hanging around some like some essays at KFC. Me and my Ignites were trying to come up with, what is the term for a group of essays? You know how they've got like a gaggle of geese, a murder of crows. There's someone said a vape of essays, like... Is that what we call them? Yeah, question?
Could that affect us in a test? Is this like subjective? So like what if we...
The next lesson after this one. Good. I like that he's come up with that term. Right now, this is all subjective. Have I chucked any numbers at you whatsoever? You need to be able to use the right words, but next lesson you'll get actual limitations to things. Numbers will be involved, okay? Outliers. Hopefully you've heard about outliers previously in science. If data points lie away from the main pattern or trend of the other data points, we say there's an outlier in the data. So, what do you see here? In the bottom left is most of the data. And most of the data tells me that there's going to be a straight line correlation to it. But there's these really far dot points. What would we say this dot is? Is that dot an outlier? Is it wrong according to the main trend? It sits on the trend, it's just far away. So that wouldn't be an outlier, not. It's not an outlier because yes, it's far away, but it lies where the trend suggests it should be. Whereas these two here, is that one at the top sitting on trend? Is that one at the bottom sitting on trend? No. So you'd say that they're outliers. There's no more notes here. There's a bit of a laugh at the end, and then I'll give you half an hour to do exercises. Please be aware that what we're talking about in Year 12 General Maths is not causality. We're just talking about correlation. So one number tends to increase or decrease as another number decreases or increases. We're not saying that one causes the other. Most of the time it is, but correlation just means that we observe one variable changes as another changes. We can't assume that the independent variable is the reason for changes in the dependent variable. It's just an assumption. If you can argue that the independent variable would at least partly affect dependent variable, then we can claim causal. But it's important to consider this. It's important to consider that it's a bit sketchy because there's some examples here. I'll go through them. I won't do them recorded because some of the spurious correlations reference some like sketchy stuff. But so I'll show that off the video. But after we've looked at these links, I'd ask you to paste your notes in your workbook and do these exercises for half an hour. So I'll stop the recording.